What we need to use is this squeeze theorem. Basically says that if f of x is some function between g of x and h of x near some value a, but just that what we have here essentially is that f of x is between these two functions for x between -1 and 2. And it also we also have that we know the limit as x goes to a of g of x. So I know the limit in this case I'm going to know. So when I'm investigating, a is going to take the role of 1. And I have limit as x goes to 1 of g of x, as we will see soon, is actually equal to the limit as x goes to 1 of h of x. And they both equal 5 in this case. If you look, the limit of this function, right, as x gets closer and closer to 1, sine this inside value is getting closer and closer to pi over 2. Sine of pi over 2 is 1, and then plus 4 is 5. So the limit as x goes to 1 of g of x is just 5, and then the limit as x goes to 1 of h of x here is a polynomial. Therefore, it's continuous everywhere, so it's always the case that the limit, if it's a polynomial, right, definition of continuity, I'm just going to review real quick, then it's going to equal a, right? If this is a polynomial, it's continuous everywhere, so this equality is always true for all a. In this case, a is 1, so it's just equal to h of 1. So if I plug in 1 to this, I'm going to get -1/4 plus 3/4 plus 18/4. And that's 20/4, which is just 5. And these two things do equal 5. So I have this being true, that the limit of the two the squeezers, let's say, are both the same. Then that means that the in-between function, we know that this function value has to be in between whatever this function value is and whatever this function value is by this inequality here. So since I found out that the limit as x goes to 1 over here is going to be 5, and then this is getting closer and closer to 5, so both of these on either side of f of x are getting closer and closer to 5 as x tends towards 1, as x tends towards 1. So that means that as f of x tends towards 1, it must be 5, and that's the conclusion here. Then this is the squeeze theorem, and then this is just 5. Just know that it sort of squeezes it. You see this inequality when you squeeze theorem, and the lower function should equal the very high function. That means that the middle function must equal that value. It sort of squeezes it like you have some upper function here, then you have some lower function right here. And you can see that they both tend towards this value. That means that if I find a function in between these two, something like this, right, and if I did it perfectly, right, so this blue function, let's say this takes the role of f, this pink top function takes the role of h, then this bottom function takes the role of g. This value along, let's say this is the x-axis, right, this takes the role of a or 1 or whatever it is, and you see that h of x is always greater than the blue function f of x, and f of x is greater than g of x. And basically the limit at h of x as x goes towards a is, whatever value this is along y, it's the same value that's along g. That means that f must have that same value as the limit as x goes to a of f of x must be that value, this value along here.